In this video, we're going to look at the precise definition of a limit. Now, because I'm trying to teach limits to kids, it doesn't matter if you don't fully understand this. Just try to understand the concept and the idea behind it. When you're older, you will be given lots and lots of exercises that will allow you to understand this, or it will allow you to understand this. But for the time being, just understand the concept and the idea behind it. So what this is saying is that suppose you have a function f of x here. In order for the limit of this function to exist here, you can give me a number epsilon here. You can give me a number that specifies the accuracy at which you want, and I can give you another number that will allow you to get to within your accuracy. Now, it doesn't matter if you don't fully understand this. Let me just give you an example. Okay, suppose you're trying to design some sort of rocket to go to the moon. Now, you don't need pi to be accurate to, let's say, 1,000 decimal places. You see, 6 decimal places would be sufficient for you. The accuracy of pi which you use, 6 decimal places is good enough. That means the accuracy at which you want it would be, let's say, 0.0001. Let's just say this. This here, you specify, this here is your epsilon, if you like. Hang on. This here, that 0.00 thingy, midget, whatever it is, that's your epsilon here. Now, by you specifying that number, you're saying, I want the limit of this, I want f of x here to be within that accuracy, within that epsilon accuracy, within that 0.0001, was it? You want it to be within this degree of accuracy. Now, I'm saying, what I'm trying to say is that it is I can then give you a number to put into f of x here. I can then specify this number here. That will allow you to get to within this accuracy here. Okay, I know it doesn't matter if you don't fully understand it. That's so if you look at this here, suppose you want to find this out to an accuracy of 0.00001 here. Let's say you want to work this out to this level of accuracy here. Now, I can then say, well, you can get to within this accuracy by choosing a number that's really, really close to 0. Let's say 0.00001. Or whatever, or maybe put this number here into your f of x here, and then you can get to within the accuracy at which you want it. My point here is that in order for the limit to exist here, in order for the limit of this to exist, you can specify any level of accuracy that you want. It is 100% possible for me to give you a number that's really close to 0 that will allow you to get to within your accuracy. So, for example, suppose you want to design a rocket or whatever to go to Pluto, and then you need to work this out at x equals 0 to an accuracy of, let's say, 0.00000 whatever here, to this level of accuracy here. Okay, I know even though you specify this level of accuracy here, it is possible for me to choose a number that's really, really, really close to 0 that will allow you to take that will take you to this degree of accuracy here. So I'm saying that there exists a number that's really close. Remember, I can always get really close to 0 here. I can put whatever this number is here that's really close to 0 into here, then that will get you to within the accuracy at which you want it. That will allow you to take it to this accuracy here. My point is that no matter what accuracy at which you want it, it is possible for me to choose a number that's really close to 0 that will allow you to get to the accuracy which you want. So, for example, if you look at this here, suppose you have a new function here. Let's say z of x here. Now, this here is the limit here doesn't exist, because suppose you want it to an accuracy of, let's say, 0.000000001. You see, I need to keep on being able to edge to get closer and closer to get closer and closer to 0. You see, if you've got a function here where it gets cut off here, then I can't get closer and closer and closer to 0 here. Well, I will continue in the next video. But yeah, I will continue in the next video.